In last session, we have discussed cross product of vectors and few problems based on the cross product we solve. So in this section, I'm going to discuss scalar triple product of any three vectors. So scalar triple product of three vectors is denoted by square bracket of vector A, vector B, vector C. You may write comma in between the vectors also. And it will be given by scalar triple product of three vectors A, B, C is given by either it is A dot of vector B cross vector C, or it may be, you may be defined as vector A cross vector B dot of vector C. So simple problems. First, I will go through the simple problems. And this one, scalar triple product means if it is zero, in case if the scalar triple product of any three vectors means is zero, means we can say that those three vectors are coplanar. Coplanar means they lies in the same plane. And if you want to find out the volume of the parallelepiped, volume of the parallelepiped also is indicated by or denoted by, or which will be given by vector A dot of vector B cross vector C, or scalar triple product of any three vectors also indicates the volume of the parallelepiped. In case if they ask to find out the volume of the parallelepiped means by giving the vectors, so just you have to find out the triple product of those three vectors, then you will get the required volume of the parallelepiped. And in case if they ask to show the vectors are coplanar means just you have to show scalar triple product of three vectors, vector A, vector B, vector C equals to 0. You may prove it vector A dot of vector B cross C equals 0, or you may prove it vector A cross vector B dot of vector C equals 0. So now I'll move on to problems, some simple problems. Find vector A dot of vector B cross C and also C dot of A cross B. So if vector A is I plus j minus k, B is 2i minus j plus 2k, C is 3i minus j minus k. So first we can find out the A dot of B cross C. So if you want to find out the A dot of B cross C, in case if you don't know the method means you may find out B cross C first. After finding the B cross, you know how to find out the B cross C just by applying the determinant of ijk, and in second row you have to note on the ijk components of B, and in third row you have to note on the ijk components of C. For the obtained result, you have to put the dot operator in between the A cross and A and B cross C. Otherwise, direct method is, so here you should not write the any ijk because it is scalar triple product. Scalar triple product means the final answer will become scalar. So scalar means there will be no ijk. So there is no ijk means just you have to note on the ijk components of A in first row 1, 1, minus 1. ijk components of B in second row 2, minus 1, 2, 2, minus 1, 2. And ijk components of C 3, minus 1, minus 1. Just you have to evaluate this one. This is so simple. So compared to cross product, it's very simple because in that cross product, ijk will be there. Here there is no ijks, only scalar values are there. So just you have to evaluate this determinant if you want to find out the scalar triple product. So just to evaluate 1, so corresponding row and column you leave. Remaining thing you put modulus, that is minus 1, 2. Minus 1, minus 1, minus 1 into determinant of 2, 2, 3, minus 1, minus 1 into 2, minus 1, 3, minus 1. So evaluate this one, 1 into minus 1 into minus 1, 1, minus 1 into 2 is 2, minus of minus 2 will become plus 2, minus 1 into 2 ones are 2, minus 2, 3 2s are 6, minus 6. So minus is there. Minus 1 into 2 into minus 1, minus 2. Minus 1 into 3 is minus 3. Minus of minus 3 will become plus 3. So if you simplify it, 1 plus 2 is 3. So here it will become minus 8 into minus 1 means it will become plus 8. 3 plus 8, 11. 11 here 1. Minus 1 it will become 11 minus 1 means it will become 10. This is the required value of A dot of B cross C. This is also known as triple product of A, B, C. Now one more, C dot of A cross B. C dot of A cross B means it will be triple product of C, A, B. Okay. So now, in first row, you have to note down the I components of C. In the second row, you should not misplace the order. You should write in the same order. First vector components in first row, second vector components in second row, third vector components in third row. 3 minus 1 minus 1, 1, 1 minus 1, 2 minus 1, 2. So it will become 3 into, so if you taken this one means 1 minus 1 minus 1, 2, plus minus of minus will become plus 1, 1 minus 1, 2, 2, minus 1 into 1, 1, 2 minus 1. So 1 2 are 2, minus 1 into minus 1 plus 1, minus of 1 means minus 1, plus 1 into 2 ones are 2, minus of minus 2 will become plus 2, minus 1 into 1 ones are minus 1, 1 into minus 1 minus 1, 1 into 2 is 2, minus of 2 means minus 2. 3 into 2 minus 1 means it will become 3 into 2 minus 1 is 3. 1 into 2 plus 2 means 4. 4 into 1 is 4. 4 plus 1 is 7. So minus 1 minus 2 is minus 3 into minus 1 is 3. 3 plus 4 plus 3, which will be 10. So next, find the volume of the parallelepiped whose co-terminal edges represented by vector A equals I plus J plus K, B is 2I plus 3J minus K, and C is I minus J minus K. Initially, I told the volume of the parallelepiped means just you have to find out the scalar triple product of the given three vectors. Just to find out the scalar triple product, A dot of B cross C is, so IZK components of A is 1, 1, 1, 2, 3 minus 1, 1 minus 1 minus 1. Just note down and evaluate. So if you evaluate this one, determinant means you will get the value as minus 8. This is the required volume of the given parallelepiped whose vertices are or co-terminal edges are given by these three vectors A, B, C, which are given by like this. So then we'll get the answer as minus 8. Just to evaluate this determinant, then we'll get the final answer as minus 8. So volume means you should not write the negative sign. Even if you are getting negative also, you should write at the end plus only. So volume of the given parallelepiped is 8 units. Next, prove that the position vectors of the 4 points A, B, C, D represented by this are coplanar. Coplanar means you have to show scalar triple product of these three vectors are 0. So here they are given the position vectors. Position vectors means it will indicate by OA, OB, OC, OD. So A is minus J minus K. So that is also indicating as OA, vector OA. B is 4I plus 5J plus K, C is 3I plus 9J plus 4K, and D is minus 4I plus 4J plus 4K. So these are the position vectors. Position vectors means initial value or initial point should be O. Then we call that return as position vectors. So now if you want to find out the, so this one, whatever you written, they are given for the A, that one will indicate OA, B as OB, C as OC, and D as OD. So now you have to find out the AB, AC, AD, then we'll get the sides. Vector AB. Vector AB means OB minus OA. So terminal one you have to take first and initial one you have to take at the end, minus. OB minus OA, just you have to subtract the vector OA from the OB. OB vector is 4I plus 5J plus K and OA vector is minus J minus K, right? So you have to subtract this one. So 4I plus, there is no I term here, so 4I as it is you have to write. 5 minus of minus J will become plus 6J. K minus of minus will become plus 2K. So similarly you have to find out the AC, which will be given by OC minus OA. So OC is position vector, C is 3I plus 9J plus 4K. OA value knows minus J minus K. If you subtract this OA from the OC means you will get 3I plus 10I plus 5K. Similarly, you have to find out the vector AD also, which will be given by OD minus OA. OD minus OA equals minus 4I plus 4J. 4K is the value of position vector D. And minus J minus K is nothing but A value. So if you subtract this one from the D means you will get minus 4I plus 5J plus 5K. So now you have to find out the scalar triple product of AB, AC, AD. So that is AB dot of AC cross AD. So which is, so here 4, 6, 2, here 3, 10, 5, and here minus 4, 5, 5. So this one should be minus 4. Yes, minus 4. So now if you simplify, this one means 4 into 10, 5, 5, 5, minus 6 into 3, 5, 4, 5, plus 2, this is minus 4, plus 2 into 3, 5, 3, 10, minus 4, 5. So they missed while writing this sign, that's why they are not getting 0. So if you make this one correct, means it will become minus of minus will become plus 20, then we will get the final answer as 0. This one you have to make minus 4. Show that the points A of minus 1, 4, minus 3, D of 3, 2, minus 5, and C of minus 3, 8, minus 5, and D of minus 3, 2, 1 are coplanar vectors. So same thing you have to show. So they are in last problem they are given in terms of IJK, but here they are given in terms of Cartesian coordinates. So they are, so first Cartesian, this first one, first position will indicate I component, this one will indicate J component, this one will indicate K component. So that means position vector A will become minus I plus 4J minus 3K, and position vector of B will become 3I 2J minus 5K, and position vector C will become minus 3I plus 8J minus 5K, and position vector of D will become minus 3I plus 2J plus K. So now you have to find out the AB, AC, AD. AB is OB minus OA. So just to directly subtract, 3 minus of minus 1 will become plus 4. 2 minus of minus 4 means it will become 1, 4 is there. 2, 4 means it will become minus 2. This will become minus 2. And here next one minus 5 plus 3 means it will become minus 2. This is right. So AC is OC minus OA. So you will get it as minus 2I plus 12J minus 2K. And AD OD minus OA, which will be minus 2I plus 6J minus 2K. Just to find out the scalar triple product of these three vectors AB, AC, AD. So here you have to make it as minus 2. Then you will get the final answer as 0. So then we can say that these three vectors are coplanar vectors. So one more type problems will come. They will ask to find out the some constants by giving the condition all the vectors are coplanar. So this one just to see, find the value of lambda so that the vectors are coplanar. So they are given the vectors, three vectors, vector A equals 2I minus 3J plus K, B is I plus 2J minus 3K, and C is J plus lambda K. J plus lambda K means here we don't know the value. This value you have to find out by assuming these three vectors are coplanar. So we know that any three vectors are said to be coplanar means their scalar triple product should be 0. So now scalar triple product is 0 means then by equating this scalar triple product equal to 0, we can find out the value of lambda. So just to find out the A dot of B cross C. So first one is 2 minus 3, 1, 1, 2 minus 3, and here there is no I component, so that means you have to note down it as 0, 1, lambda. Simply and equate it to 0. Simplify this determinant, 2 into determinant of 2 minus 3, 1 lambda, plus 3 into 1 minus 3, 0 lambda, plus 1 into 1 to 0, 1. So simplify this one, 2 into 2 lambda minus of minus 3 will become plus 3 into lambda minus 0 plus 1 into 1. This will become 0. So now simplify this one, 2 into 2, 4, 2 lambda means it will become 4 lambda plus 2 into 3 is 6 plus 3 lambda plus 1 equals 0. So it will become 7 lambda plus 4 lambda plus 3 lambda is 7 lambda, 6 plus 1 is 7, which will be equals to 0. Lambda equals minus 7 by, if you shift this 7 to right hand side means it will become minus 7 divided by 7, which is equals to minus 1. So one more concept is vector triple product. Vector triple product means just if it is cross in between all the vectors means it will become vector triple product. So that is A cross of B cross C. So how you have to find out this one means first you have to find out the B cross C and then same method. So by assuming this one as one vector, then you can find out the one more vector. So just to see, A is, so if vector A equals A 3 minus 1 4, B equals 1 2 3, C is 4 2 minus 1, Then find the vector A cross of B cross C. Vector A equals 3i minus j plus k, B is I plus 2j plus 3k, and C is 4i plus 2j minus k. So first find out the B cross C, ijk. So ijk components of B is 1, 2, 3, and this one is 4, 2, minus 1. If you find out the cross product of B cross C means you will get it as minus 8i plus 13j minus 6k. So now A cross of B cross C means you have to consider this one as single vector. So you have to consider this one as single vector. So here this one you have to note down in the third row, minus 8, 13, minus 6. Ijk components of A you have to note down in second row, 3, minus 1, 4. Just you have to evaluate this determinant, then you will get the required vector. So this is final answer, you will get it as minus 46i minus 14j plus 31k. Thank you guys. Thank you all.